All right, guys, welcome to this quick video on how to use inverse trig functions to solve for missing angles of triangles. What we've done so far has been using trig functions to find missing sides, but if we need to find missing angles, we need to use inverse trig functions. Okay, so bear with me as we quickly go through this process. Remember that yesterday we said that if we're focused on angle A, I could find the tangent of angle A by using my opposite over adjacent, which is 30 over 40. Right? And so if I were to take that, and I'm really not interested in what the tangent is, but I'm really interested in what the measure of A is. I need to, actually, that was not what I wanted to do. Oh my gosh, what was that? There we go. Okay, remember that we said that we are going to have to isolate A. What we need to do is take the tan inverse of both sides of the equation. We take the tan inverse of the left as well as the tan inverse of the right. Okay, and so what that does is on the left-hand side, if I have an inverse and the same function, then it undoes each other, like addition and subtraction of the same value or multiplication and division. So these go away, and I'm just left with A is equal to tan inverse of 30 over 40. And at that point in time, you're going to grab that handy dandy calculator and you're going to nicely ask it, what is the tangent inverse of 30 over 40? And to do that, you will use that blue button, second function, and the tan function. So second tan, which will give you tan inverse, and then 30 over 40. And you should end up with, I think, like 36.9 degrees. And when we're talking about degrees, we can round to the nearest tenth, but most frequently when we're talking about degrees, we're going to just use the nearest whole degree. That's not true on side lengths, but it is for angle measures. Okay, let's look at a couple of examples. Let's start with this one. So let's look at the angle measure we have here. So we've got some trig function, I'm not sure which one, of x degrees is equal to something over something. And what are those somethings? What do we know? We know the hypotenuse and we know the opposite side, right? So which trig function, sine, cosine, or tangent, has opposite and hypotenuse? That will be sine of x, and the sine is the opposite over the hypotenuse, so that's going to be 9 over 14. Okay, now again, since I want to undo the sign or get rid of the sign and just have x, what I'm going to do is take the sine inverse of the left-hand side and the sine inverse of the right-hand side. So sine inverse of sine of x and the sine inverse of 9 over 14. And then on the right-hand side there, we have what we are going to calculate. On the left-hand side, we just got x, right? X degrees is going to equal sine inverse of 9 over 14. So I think when you do that, you end up with something along the lines of sine inverse of 9 over 14. That's going to be 40. So x is going to equal 40. The angle measure in that angle is 40 degrees. Outstanding. Now, just for kicks and giggles, because we can, if we know that this angle is 40 here, what would this one be? Well, the 3 must add up to be 180, right? So I've got 40 plus 90 plus something equals 180. That would have to be 50 degrees. All right, let's go to example 2. Example 2. All right, same idea. Very same idea. What we're going to do here is set up an equation, some trig function. Oops, let's go back. Some trig function of something degrees, right, is equal to something over something. And we know that the degrees is x degrees. Now, with this diagram, we know the opposite side and we know the adjacent side. So, which trig function uses opposite and adjacent? Opposite and adjacent, that's going to be tangent. Tangent of x degrees is going to be opposite over adjacent. So in this case, it'll be 21 over 25. Now again, we're going to isolate that tangent of x degrees by taking the tan inverse of both sides of the equation, left side and right. Okay. And then our tan inverse and tan on the left cancel out. We just get x degrees equals tan inverse of 21 over 25. Grabbing that handy dandy calculator. Let's see what that happens to be. Tan inverse of 21 over 25. I think that's going to give us, about 40 again? Well, that's kind of crazy. But it's true. So our angle measure is going to be 40 degrees. All right, next one. All right, we're going to do a couple more here. All right, and for this one, same idea. Always start with trig function of something degrees equals something over something. We know the something degrees is going to be x degrees, right, from the angle that's inside. And then to find our trig function, I need to look at what I know. I know with this triangle, I have the hypotenuse and I have the adjacent side. So which of my trig ratios uses adjacent and hypotenuse? That is going to be cosine. Cosine is adjacent over hypotenuse, or 44 over 52. All right. So let's go ahead and undo the cosine by using cosine inverse. So cosine inverse of the left side, cosine inverse of the right side. All right, and then easy peasy, cosine inverse and cosine cancel out, and I know that x will equal cosine inverse of 44 over 52. All right, and grab that from your calculator. What is the cosine inverse of 44 over 52? Let's see. Looks like about 32.2 degrees, so we'll call that 32 degrees if we round to the nearest whole degree. All right, for bonus points here, if x is 32 degrees, what is the other triangle angle measure, that other acute angle. And hopefully, if you crunch that in your calculator, pause if you want to figure it out by yourself, but it should end up being 58 degrees. Okay, nice. All right. Another one. All right. And by the time that you feel like you have got the hang of this and you want to practice on your own, you're free to go on over to Delta. There's an assignment for using trig inverse functions to find angle measures. Okay. All right. So here we go. Let's go here. We're going to look at the same thing. Trig function of something degrees equals a fraction, something over something. We know the degrees is x degrees. And with this triangle, I know the adjacent side. And I also know the opposite side. So which function uses opposite and adjacent? That's going to be tangent. Tangent of x is going to be opposite, which is 6, over adjacent, which is 10. So let's take that and duplicate it. And let's use our tan inverse. Okay, so we'll use tan inverse here. And we'll use tan inverse here. Okay. And tan inverse of tan, that's going to cancel out. We'll end up with x is equal to tan inverse of 6 over 10. Grab your calculator to find out what that is. I don't know what it is off the top of my head, but my calculator says that the tan inverse of 6 over 10 is about 31 degrees. All right. And if you feel like you get it, it's time for you to practice. If you want to follow along for these last couple of examples, then we will do that. Okay. So we have 2 more examples left. Hang with me if you want. Practice if you want. All right. Let's set up the equation. Can you set it up? Okay, definitely know that we've got x degrees here, and we need to figure out which of my ratios I'm going to use. I know that this is my hypotenuse, and I know that this is my opposite side. Okay, opposite side here. Opposite and hypotenuse, that is my sine function. My sine function is opposite over hypotenuse, so it'll be 31 over 38. All right, so let's use our sine inverse on both sides. In a second, there we go. Our sine inverse on both sides. Sine inverse of sine of x. And sine inverse of 31 over 38. Now the sine inverse of sine cancels, and we are left with x is equal to sine inverse of 31 over 38. And what is that? What is sine inverse of 31 over 38? Looks like about 55 degrees. Is that what you got? Always good to have somebody check me. All right, 55 degrees. And the very last one, All right, let's do it. Let's do it. All right, we got something of something degrees. Some trig function of something degrees equals a fraction, something over something. Okay, we know that that angle measures x degrees. Perfect. Okay. Now, what do I know in this triangle? I know my hypotenuse. All right. And I also know my adjacent. So which trig function is adjacent in hypotenuse y? That's cosine. And cosine is adjacent over hypotenuse, so 19 over 24. Using our sine inverse on both sides, or I'm sorry, not sine inverse, it's cosine inverse. Oh, what was I thinking there? Cosine inverse on both sides. Cosine inverse on this side as well. And we'll put our cosine inverse of cosine of x and cosine inverse of 19 over 24. Okay, we definitely know that these will cancel and we will end up with x degrees equals cosine inverse of 19 over 24. Let's grab our calculator and see what that ends up being. Okay, it looks like cosine inverse of 19 over 24 is about 38 degrees. All right, and that wraps up the examples. You need to hop on over to Delta, okay, and give it a shot. Hope this helps you with inverse trig functions. Here, I need you to remember this much. An inverse trig function is used to find an angle measure. A regular trig function is used to find a side length. Okay, and I'm going to sprinkle that all the way through that Edpuzzle for you.